Welcome back. So we've been talking about multivariate regressions, and today we are going to learn how to use those regression estimates to make predictions. So we've done this with one x variable, one y variable regressions already, and it's a really similar idea with a multivariate regression. We just have more moving pieces to work with. So let's say I'm trying to predict how well someone is going to do on a quiz, let's say the second quiz in this class, and I have data on the first quiz. So we've plotted a scatter plot of that. We've talked about that, how we may be able to use how you do on a first quiz to predict how well you'll do on the second quiz. But let's say we also have information on some homework assignments. So let's say the homework from Chapter 2 material and the homework from Chapter 3 material, which is what this second quiz covers. So that means we have three x variables, quiz 1, homework chapter 2, homework chapter 3, to predict the grade on the second quiz, which covers chapter 3 material. So if we run the numbers on those, we find that we have a positive and statistically significant coefficient on the homework for chapter 3 and on the first quiz score. We don't have a statistically significant coefficient on the chapter 2 homework variable. So what does this mean? Well, it means that if we're trying to predict how well someone's going to do, we're going to predict that those who did well on the first quiz are going to do well on the second quiz, and we predict those who do well on the homework for chapter 3 are going to do well on the second quiz that covers chapter 3. What we can also take away is that how you do on the homework for chapter 2, different material, does not have explanatory power, does not help you make a better prediction about how well someone's going to do on chapter 2. So there's the intuitive part. That's the interpretation that we did with the last lesson when we looked at the sign and statistical significance of each coefficient in a multivariate regression. We can actually take it a step further and make an actual prediction. So if we have coefficients, so this data comes from a roughly 10-point scale. So the quizzes were out of 10 points. We look and we see there's actually a constant for the regression. That means there's an intercept, and that's 2.4, and it has a star next to it. So we're going to include that in our prediction model. So our prediction model is basically going to use all of the coefficients that have stars next to them that are statistically significant, and we're going to include them in a calculation to figure out what we expect a y to be. So for everyone, we're going to add this intercept, this constant of 2.42, and we're going to take whatever someone got on quiz 1. So let's say someone got 7 points out of 10 on quiz 1. We're going to multiply that by the coefficient we have for quiz 1. In this case, it's 0.51. So we would take 7 and multiply it by roughly a half, and we'll end up with a number that's about 3.5. We're going to add that to the 2.4 that was our constant, and then we're going to add the homework for chapter 3 is the other statistically significant coefficient. So that coefficient is 0.26, and let's say someone got 10 points on their homework for chapter 3. So that would mean we're going to be adding 2.6 to our prediction. So our prediction is going to have three pieces in this case. We've got the constant of 2.4. We've got the quiz 1 portion, so that's the 0.51 times, we said they got 7 points, so we're adding 3.5 with that. And then we've got the 0.26 times the chapter 3 homework, we said they got 10 points, so we're adding 2.6 there. And we end up with a prediction for how they do on quiz 2, adding those three pieces up, taking the scores they got, multiplying it by the coefficient coming out of our regression. That's how we come up with a prediction. I actually don't know the math, but it would be 2.6 plus 2.4 gives us 5, and we said the other one was 3.5, so we predict they get 8.5 points out of 10 on quiz 2 based on that regression model. That's how we come up with a prediction based on a multivariate regression. We take all of the coefficients that have stars next to them, and we look at the data for that individual for quiz 1, for homework for chapter 3. We add the constant for everyone, but the other ones, we multiply the coefficient from the regression by the value that person actually got. Now, one other move that we can make, that we are making, we can start including categorical variables in regressions. So far we've said, hey, regression is something where you should have a quantitative variable on both the y-axis and the x-axis. We don't actually need that. So we're going to start taking advantage of the power of being able to include categorical variables in our regression models. So for example, let's say we have data on whether a student is an upperclassman or not, or maybe whether they're what their major is, other categorical variables, right? Well, if we have data on that, we can use that to help make a better prediction. We can throw those variables into the model, and we're going to get coefficients for those things. Let's say we use a binary variable. Let's say we have a variable for upperclassmen, and it's a 1 for people who are a junior or a senior, and it's a 0 for everyone else. So there are two possibilities for that categorical variable. That's why I call it binary. You're either an upperclassman or you're not. When we have a variable like that, and we'll see those a lot in this sort of data, the way we'll use that in our prediction is we look at the coefficient on that variable coming out of the regression. If it has stars next to it, for someone who is in this category, who has a value of 1 there, we're going to add the coefficient. So in this case, we run a regression, and upperclassman has a coefficient of 0.41 with a star next to it. So our prediction for each upperclassman going forward is going to have that 0.41 added. You may notice the coefficients can change a little bit. If we add a new variable, it means the other coefficients are going to be slightly different as well. Before we may have had 0.24, now we have 0.26, etc. But yeah, we include all of the variables we have information on, including categorical ones. We look at the coefficient coming out of the regression, and we add those up, multiplying the value that we have times the coefficient coming out of the regression, adding all of those up, including the constant as long as it's significant, and the result coming out is the prediction that we have for our y variable for that person. And so this is actually how Amazon decides what you might want to buy next. They have a bunch of data on people that look kind of like you. They look at what they've bought next after buying at one thing and looking at one thing. They'll put in the data they have for you and use that to figure out what they think you might do next with prediction models, much like this. They have a lot of data, so they can make pretty good predictions. And that's largely the business model for a lot of these big tech firms. They have a lot of data that allows them to make pretty good predictions about what ads you might want to see, what movie you might want to watch. They can help tailor things to be very individualized for you. That means to people who want to advertise products, these people can be really valuable. That's why Google makes a lot of money, Facebook makes a lot of money, etc. They have a lot of data, and they can use that to make predictions with this sort of model. So thank you for hanging with me. I know multivariate stuff can get kind of complicated kind of quickly, but it's really important. We use it in research a lot. So we'll be talking about some of the coronavirus research that's coming out. It's being made at a very fast pace because understandably people are thinking about this a whole lot, very concerned about this. So we'll end up looking at regression results. That is often the form that a lot of research results take. And now we've got the tools to be able to look at those results and see what they're controlling for, what they're not controlling for. we're able to look at if they're making predictions about what may happen next in a particular state or a particular country with coronavirus based on what happened in other countries. We can look at kind of what's going into their prediction model. Are they basing it on things? Well, how many types of information are they using as inputs to make that prediction? So thank you guys for hanging with me through this. Reach out to me with questions that you have about this material, because I know it's complicated and it's difficult to share my excitement for some of this through the distance format, but doing the best I can. I ask that you reach out when you have questions, and I'll get back to you in a timely manner. Thanks.